Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared from the IIT JAM mathematics exam held in 2025. Today we discuss the solutions of 4 problems from the section real analysis and which are related to the functions of one real variable. And it is the third part of the 3 parts of the video devoted for this title. These problems are suitable for all these examinations. Right. This is question number 43 for 1 mark, which is a numerical answer type question. The given question is, let alpha be the real number such that limit extends to 0, 1 minus cos x in brackets multiplied by 2 power 2 plus x minus 4 in brackets by whole by x cube is equal to alpha log 2 ln 2. Then the value of alpha is equal to dash round off to 2 decimal places. Right. Let's now discuss the solution of the problem in detail. Now we want to find the limit of this, which is equal to alpha ln 2. That we write it as alpha ln 2 is equal to limit extends to 0. Numerator is 1 minus cos x in one bracket multiplied by 2 power 2 plus x minus 4 in the other bracket whole by the denominator x cube. Now this we separate it. Limit of the product is equal to product of their limits, and that is limit extends to 0 1 minus cos x by x square into limit extends to 0 2 power 2 plus x we have written as 2 square into 2 power x minus 4. 2 square is 4 and whole by x, and 2 square is 4, we can take 4 common. Right. This is equal to limit extends to 0 1 minus cos x by x square into 2 square is taken common, that is 4 times limit extends to 0 2 power x minus 1 by x. Look at the functions. As x tends to 0, 1 minus cos x tends to 0 by x square 0, 0 by 0 form, and as x tends to 0, 2 power x minus 1 is 0 by x, that is 0, 0 by 0 form. Use LHR. LHR means the L'Hopital's rule, the so-called L'Hopital's rule. Right. And that is equal to limit extends to 0, derivative of the 1 minus cos x, that is sin x, by derivative of x square is 2x into 4 into limit extends to 0. The derivative of 2 power x minus 1 is 2 power x log 2 by differential of x is 1. Agreed. Agreed. And this is 1 by 2 comes out from here. This is 4. 4 by 2 is 2. So that is 2 times limit extends to 0 sin x by x, which is a very well known limit, into ln 2 is a constant multiplied by limit extends to 0 of 2 power x. And it is very well known, limit extends to 0 of sin x by x is 1, and limit extends to 0 of 2 power x is 2 power 0 because it is a continuous function. So 2 power 0 is 1. So that is 2 into 1 into ln2 into 1, and that is 2 times ln2. So which is equal to, given to be alpha times ln2. So from this we get alpha is equal to 2, required to find the value of alpha, which is to be rounded off to 2 decimal places. Therefore the answer to this question is 2.00. That is the detailed discussion of the solution of this problem. It's a very simple and straightforward question. Move to the next question. Right. This is the question number 51 for 2 marks, which is a NEAT, that is a numerical answer type question. The given question is, let f be a continuous function from R to R, satisfying integral 0 to pi by 4 of, in the bracket, sin x times fx plus cos x multiplied by integral 0 to x ft dt, it's all in one bracket, with respect to x is equal to root 2. Then the value of integral 0 to pi by 4 f of x dx is equal to, the answer is to be given, to be rounded off to 2 decimal places. Right. Now, let's now discuss the solution of the problem in detail. We have the given integral. Integral 0 to pi by 4, inside the bracket, sin x fx plus cos x integral 0 to x ft dt, this is all in one bracket, multiplied by, with respect to x, is equal to root 2. Agreed. So this implies is a integral of the sum of 2 functions, so which we will write as sum of the integrals, integral 0 to pi by 4, first function, sin x fx dx, plus integral 0 to pi by 4, the second one, in the bracket, cos x integral 0 to x ft dt, bracket closed, with respect to x, is equal to root 2. Let's call this as the equation 1. Take this second integral, right, and evaluate, and then come back to equation 1. Now, integral 0 to pi by 4 cos x integral 0 to x ft dt with respect to x, right. We integrate it by parts, integration by parts we do. Here we identify this as my first function, that is integral 0 to x ft is my first function, cos x is my second function. We apply integration by parts. This is equal to first function, integral 0 to x ft dt into integral of cos x is sin x, to be evaluated between x is equal to 0 to pi by 4, minus integral 0 to pi by 4 derivative of the first, that is d by dx of integral 0 to x ft dt, multiplied by integral of second function cos x, that is sin x, with respect to x. Now evaluate this between the limits x is equal to 0 to pi by 4. So wherever there is x, you write pi by 4. So that will be, and here d by dx of integral 0 to x ft dt, d by dx of integral 0 to x ft dt is f of x. It's well known. It is well known. Right. Now substitute the values. So 0 to pi by 4 ft dt multiplied by sine of x, x is pi by 4, minus for the lower limit x is equal to 0, integral 0 to 0 is 0. So we have not written, minus integral 0 to pi by 4 d by dx of integral 0 to x ft dt, which we have said f of x into sin x. Sin pi by 4 value is 1 by root 2. That is 1 by root 2 into integral 0 to pi by 4. Ft dt is same as integral 0 to pi by 4 fx dx. After all, the variable of integration is a dummy one. Therefore, for t, we can also write x, right? Minus integral 0 to pi by 4 f of x sin x dx. Right. We get back to equation 1. Equation 1. So, equation 1 becomes integral 0 to pi by 4 sin x f of x dx plus, for the second one, we have integrated here, that is 1 by root 2 integral 0 to pi by 4 f of x dx minus integral 0 to pi by 4 f of x sin x dx. And integral 0 to pi by 4 f of x sin x dx, and here they will cancel. This is plus, this is minus, cancel, and we are left with this one, the middle one. And that will imply 1 by root 2 integral 0 to pi by 4 f of x dx. Cross multiply, we will get integral 0 to pi by 4 f of x dx is equal to 2. That is to be evaluated, and we got the answer. Therefore, the answer to this question is 2.00, which is to be rounded off for 2 decimal places, therefore 2.00. That is the detailed discussion of the solution of this problem, and it is a very simple and straightforward question. Let's move to the next question. Right. This is question number 53 for 2 marks, which is again NEAT numerical answer type. The given question is let f of x is equal to 2x minus sin x for all x belongs to R. Let k be a natural number such that limit extends to 0 in brackets 1 by x sigma I is equal to k I square into f of x by I bracket close is equal to 45. Then the value of k is equal to dash. Let's now discuss the solution of the problem in detail. We have f of x is equal to 2x minus sin x for all x belongs to R. Right. And look here, f of x by I is there. I is the variable of summation. Right. F of x by I, wherever there is x, you write x by I, 2 into x by I minus sine of x by I. For sine function, let us write down its Maclaurin's expansion. That is 2 into x by I minus expansion of sine of x by I is x by I minus 1 by 3 factorial into x by I whole cube plus 1 by 5 factorial into x by I whole to the power of 5 minus so on and so forth. But in these 2 into x by I minus x by I is x by I minus into minus plus 1 by 3 factorial into x by I whole cube minus into plus is minus 1 by root 5 1 by factorial 5 into x by I whole to the power of 5 plus so on and so forth. Agreed. Get back to the limit. 45 is equal to limit extends to 0 1 by x integral summation sigma I is equal to 1 to k I square f of x by I. Right. Now take this 1 by x inside the summation. I square by x is written as I into I by x. So we have written sigma I is equal to 1 to k I into I by x into that f of x by I we have written here. And limit extends to 0. Agreed. Now I by x multiply here and inside x by i's are there. So you will get limit extends to 0 sigma I is equal to 1 to k I plus I by root 3 into x by I whole square minus 1 by root 5, 1 by factorial 5 into x by I whole to the power of 4. Right. Now as x tends to 0, limit, this will be 0, this will be 0, all the terms except this I are 0. Therefore we got sigma I is equal to 1 to k of I. This is the sum of the first k natural numbers, that is k into k plus 1 by 2. But it is given k into k plus 1 by 2 is 45, and that will give you k square plus k is equal to 90. That will give you k square plus k minus 90 is equal to 0. K plus 10 into k minus 9, they are the factors, is equal to 0. This will imply k is equal to 9 because k is given to be a natural number. The other value coming out from here is k is minus 10, which is not a natural number and hence rejected. Thus the value of the k is 9. The answer to this question is 9. That is the detailed discussion of the solution of this problem. It's again a simple and straightforward question. Let's move to the next question. Right. Is the question number 54 for 2 marks, which is a NEAT numerical answer type. The given question is the value of the infinite series sigma n is equal to 1 to infinity n into 3 by 4 to the power of 2 times n minus 1 is equal to be rounded off to 2 decimal places. It is a leftover of a problem from infinite series which I have forgotten to include this at the sequence and series, and hence it is coming. It is not to be listed under functions of one real variable. It is to be listed under infinite series. Anyway, find the value of the infinite series means find the sum of these infinite series. Let's now discuss the solution of this problem. Sigma n is equal to 1 to infinity n into 3 by 4 to the power of 2 into n minus 1. We write 3 by 4 whole square to the power of n minus 1. That will be sigma n is equal to 1 to infinity n times 3 by 4 whole square is 9 by 16 whole to the power of n minus 1. 9 by 16 is strictly less than 1. Agreed. But this is very well known series, What are this? N, sigma n is equal to 1 to infinity n, this goes in arithmetic progression. 9 by 16 to the power of n minus 1, this goes in geometric progression. And that is why such a series is called an arithmetico-geometric series. And how to find the sum of such things which we are very familiar right from plus 2 level, right? And recall sigma n is equal to 1 to infinity nx to the power of n minus 1. This is the arithmetico-geometric series, which is equal to 1 by 1 minus x whole square when mod x less than 1. That is the sum of this series is this one. And under binomial theorem also we have studied 1 plus 2x plus 3x square plus 4x cube plus so on and so forth. This is precisely sigma n is equal to 1 to infinity nx to the power of n minus 1. Under binomial theorem we get this one. This is equal to 1 minus x to the power of minus 2 when mod x less than 1. This is one and the same. One and the same. So in our discussion, our x is 9 by 16, which is less than 1. Therefore, sigma n is equal to 1 to infinity n into 3 by 4 to the power of 2 times n minus 1 is equal to sigma n is equal to 1 to infinity n times 9 by 16 to the power of n minus 1, where 9 by 16 is less than 1. Therefore, the sum is 1 by 1 minus x whole square, where x is 9 by 16. Right. And take the LCM. This is 16 minus 9 by 16, that is 7 by 16 and whole square. That will be 16 square by 7 square, that is 256 by 49. On division, we'll get 5.22. Right. So, the value of the infinite series, rather the sum of these infinite series, is 5.22. That is the detailed discussion of the solution of this problem. It is very simple and straightforward question. Right. So in this video, I have discussed the solutions of 4 problems. They are all simple. I am sure that you have understood the solutions of all these problems. Thank you for watching this video. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure we are going to meet you, all of you, once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.